All right, this is the review for topic 7. So we had two sections, 7.1 on dilations and then 7.3 on similar figures. So dilations were simply expansions or contractions away from a certain point. So for here, our center of dilation is going to be the origin 0, 0. And this is a contraction. We're going from the blue one to the red one. So we're going from A, B, C to A prime, B prime, C prime. And so the question is, what is the scale factor? How much smaller or how much larger is it getting? So the easiest way to do this, there's two ways. You can look at the lengths of the sides. So we could pick a side, for example, AB, find the length, and then find the length of A prime, B prime, and then use a ratio there. Or we can look and see how far away the points are getting, or how much closer they're getting from the center of dilation. So I notice here we have B and B prime are simply going straight down. So if I look at B, I notice B that is 1, 2, 3, 4 units down. So the length there of from the origin is going to be down 4. We're going down 4. Right? And then I notice B prime, right, is just down 1. So um, instead of going down 4, we're going down 1. So our ratio, it can either be 4 over 1 or 1 over 4. And since we're going from blue to red, we're getting smaller. We want the scale factor that is less than 1. So 1 over 4. Okay, so all the points on the red triangle are 1/4 as far away from the center as the blue points. The lengths of the sides of the red one are going to be 1/4 the length of the sides of the blue one. Okay, next question. So let's look at the length of the side of AB here. So AB is 1, 2. I don't want that pen. All right, the length of AB here is 2. Okay, and then A prime, B prime is going to be 1, 2, 3, 4, 5, 6. So our figure, again, ABC to A prime, B prime, C prime, this one's getting bigger, so the ratio should be greater than 1. So if you looked at your ratios, you could do one of these, right? We're going bigger, so we want 6 over 2, right? And then we simply can reduce that to 3 over 1, or just 3. Okay, so the red one here is going to be 3 times as big as the blue one. We're doing that by comparing the lengths of AB. So AB here is 2, and then A prime, B prime here is 6. So it's getting 3 times bigger. All right, the next one here, we have points 9, 3, negative 3, 6, and 0, negative 6. And we want to find the coordinates after we dilate the figure according to this notation here. So we're going to do a dilation with a scale factor of 1/3 to triangle XYZ. So I'm going to first graph triangle XYZ in blue. Graph the pre-image in blue. So we have 9, 3. That's going to be X. We have negative 3, 6. That's going to be Y. And then we have 0, negative 6, which is going to be Z. Right, and we can connect those best we can for a triangle. Okay. Scale factor is 1/3, so all we need to do here is multiply our coordinates by 1/3. So 9 over 3, I'm sorry, 9, x is 9 over 9, 9 comma 3. If we multiply that by 1/3, we're going to end up with 3 comma, well, we can, let me do this. So 9, 3, negative 3, 6, and then 0, negative 6 are the 3 points. Okay, and then when we multiply by the scale factor of 1/3, we should end up with 3 comma 1. negative 1 comma 2, and then 0 comma negative 2. So we're just simply multiplying by 1/3. 9 times 1/3, 3 times 1/3. Negative 3 times a third, 6 times a third. 0 times a third, negative 6 times a third. And then we can graph our points. So 3, 1, this will be x prime. Negative 1, 2 will be y prime. And then 0, negative 2 will be z prime. Okay, and there's your dilation, right? All the points are getting 3 times closer to the origin, right? The origin is our center of dilation because they're not telling us. And if they don't give you a center of dilation, it's the origin. And when it's the origin, you can just multiply by the scale factor. So all the points are getting a third as close to the center of that, towards the origin. Right. Next question here. Right, and this one's going to be pretty much the same thing here. So we want to graph the original in blue. Our scale factor here is going to be 2. So we got 0.11. That's x. We got 0, negative 2. That is y. And we got negative 1, 3 is z. So here it, oops, z. So there's our original. All right, we have 1, 1, 0, negative 2, negative 1, 3. Okay, so when we dilate, we're just simply, right, the center is 0, 0, center of dilation is 0, 0, the origin. So we're just multiplying all these coordinates by 2. So this is going to become 2, 2. This will become 0, negative 4. And this will become negative 2, 6. Right? Everything's just getting twice as far away. So here's x prime. So negative 2, 6 should be z prime. Then y prime, 0, negative 4. So there's your dilation. That triangle is twice as big as the blue one. Okay. So those two are if you have a center of dilation that is the origin, 0, 0. If we have a center of dilation that is different from the origin, that's going to be number 5 and number 6 here. So we want to look and see how we're going to do this. Okay, so our coordinates are 1, 2. So there's x at 1, 2, x. Y is negative 1, 3. So there's y. And then z is negative 2, 0. So there's z. So here's our triangle. So we have 1. So should have done that in blue. Let's redo that in blue. So 1, 2, x, y. Okay, so we have 1, 2, negative 1, 3, and negative 2, 0. Those are the originals, right? We're going to go figure out the new ones here. Okay, so we got to figure out the new ones here. So our scale factor is 3, and the center of dilation is x. So all these points are going to get 3 times as far away from point x. So let's look at our diagram here. So x is at point 1, 2. Right, so since x is the center of dilation, it's not going to change. It's going to stay the same. So x prime here is going to stay at 1, 2. Right, so 1, 2. Right, x prime is the center of dilation, so it doesn't move. Okay, and then the other two are the ones we're going to have to figure out how far away they are. So y here, we're going to figure out how far away it is from x. Okay, so y is going to be 1 up and 2 to the right. So y is going to be 1 up, so up 1, 2 to the right. I don't know if we can see, that's probably too light. I wanted to use a light color, but that's fine. Okay, we're 1 up, 2 to the right. Okay, the scale factor is 3, so we need to triple it. We need to make those 3 times as far. So we need to go 3 up and 6 to the right. I'm sorry, it's left. It's left. 6 to the left. Okay, so 1 up, 2 left. So we need to go 3 times that. So we need to go 3 up and then 6 left. And that's going to put us at negative 5, 5. So that is y prime. Right, it'll be negative 5, 5. X prime stayed the same. That was 1, 2. All right, so negative 1, 3. We're going to expand that away from x 3 times as far away. So instead of going up 1 over 2, we're going to go up 3 over 6. That's negative 5, 5. All right, and then z. So z is down 2, left 3. So down 2, left 3. So we got to triple it. So we want to multiply by 3. So we're going to need to go down 6 and left 9 from the center of dilation. We're moving from the center of dilation. So to get from x to z, we go down 2, left 3. So now we need to go down 6 and then left 9. And that's going to put us here at negative 4, negative 8, negative 4. Okay, and that's going to be z prime. That was really bad. Okay, so z prime. Okay, so we're expanding out that blue triangle by a factor of 3. So negative 2, 0. Right? We went down 2, left 3. We want to go down 6, left 9, and that's going to put us at negative 8, negative 4. So next question here. So we're going to do blue as the original. Right? So our original points are 5, 1, negative 3, 3, and negative 2, 2. Negative 2, negative 2. So there's our original triangle. Okay. Center of dilation is y. Scale factor is 1/2, so this is a contraction. It's going to get smaller. So all the points are going to get closer to y. So we do know y prime right away. Y prime should stay the same because y is the center of dilation. So if we go to red here, y prime should absolutely stay the same. So you're going to have negative 3, 3. Right is going to go to negative 3, 3. So y prime stays the same because it is the center of dilation. All right, let's look at x first. So how do you get from y to x? So to get to x, you got to go 1, 2, 3, 4, 5, 6, 7, 8 to the right. 1, 2 down. So 8 right, 2 down. Scale factor is 1/2, so we multiply that by 1/2. So instead of going 8 to the right, we only want to go 4 to the right. And instead of going 2 down, we only want to go 1 down. So we go back to our center of dilation. And instead of going 8 right and 2 down, we're going to go 4 right and 1 down. And that's going to put us right here. And that's going to be x prime. Excuse me. So instead of going 8 right and 2 down, since the scale factor is a half, we're going to go 4 right and 1 down. So this point is getting half as close to y, or really half as far from y. Okay, so x here, so this was what, 5, 1 is going to go to, this is 1 comma 2. 1 comma 2. Now we look at z. So z is 1, 2, 3, 4, 5 down, 1 to the right from the center of dilation. So it's 5 down, 1 to the right. Scale factor here is a half. So instead of 5 down, right, we want to go 2.5 down. Right, instead of 1 to the right, we only want to go 0.5 to the right. So we go back to our center of dilation, which is y. We go down 2.5, and we go right half. It's going to put us right here, which is going to be negative 2.5. And then up a half, so 0.5. Right, so we're going from negative 2, 2. Sorry, negative 2, negative 2. Right, and we're going to negative 2.5, 0.5. Okay, so that's z prime. Then as we said again, y prime was, y is the center of dilation, so y prime stayed the same. So y prime is the same spot. And there's your contraction, your dilation, right? All those points are getting half as far away from point y. It's shrinking in size by a half. Or really shrinking in size by 2, but getting half as big. Okay, so that's really it for 7-1. The rest of these questions here are from 7-3. So let's look at those questions. Okay, so question 7 here, are the triangles similar? What I notice here, first of all, are the angles. So I notice we got to check and see if sides are proportional, angles are congruent. But we can just use angle-angle similarity here. We know the three angles of a triangle add up to 180. So we can do 180 minus 90 minus 67. And that's going to be 23. So this angle here has to be 23. And so since we have two pairs of angles that are congruent, right, angle M is congruent to angle P. Right, and then right angles are congruent, so angle J is congruent to angle N. We have two pairs of angles, so we can say yes by angle-angle similarity. Right, yes by angle-angle similarity. Two pairs of angles congruent. We could have also checked the sides as well. So you could have set up ratios here, 26 over 39. Right, you could have done 24 over 36. And then 10 over 15. And all of these would reduce to 2 over 3. So all these ratios would be 2 over 3. So you could have also used side, side, side. And then that also means you could have used side, angle, side, right? If you would have used these two, and then angle J and angle N, right? Then you could have also used side, angle, side. So in this case, all three possibilities would work. Angle, angle, side, angle, side, and side, side, side. All right, number 8. Okay, here we have 60 degrees, 60 degrees, 62, and 54. So we know the three angles of a triangle add up to 180, so we can find the missing angles here. So 180 minus 60 minus 62. That's minus 122, that's going to be 58. So angle C here is 58 degrees. And if we notice, this is not going to match up over here, right? This is 54. 58 does not match up with 54. 62 does not match up with 54. So we're only going to have one pair of congruent angles. So the triangles are not going to be similar, okay? Because we only have, you know, one pair of congruent angles. Make sure you put an explanation in there. There's only one pair of congruent angles here. Not enough. Right? In fact, we know the other ones are not congruent, so we know for our, we can prove and show with 100% certainty that the triangles are not similar. All right, the next one here. We have one pair of angles congruent, right? Angle Q is congruent to angle K. That's not enough yet, though. We have to check the sides, so we have to see if the ratios are equal. So 12 will match up with 15. 9 will match up with 12. Okay, if we reduce these, divide by 3 on the top and the bottom here, you're going to get 4/5. Divide by 3 on the top and bottom here, you'll get 3/4. So those are not equal. Since the ratios of the corresponding sides are not equal, we know that those sides are not proportional. And since the sides are not proportional, we can say no, and then you can give your explanation. They're not similar because the sides are not proportional because the ratios of the corresponding sides are not equal. We have one pair of congruent angles, but the sides are not proportional. All right, number 10. Okay, I like to start with the angles, so I'm going to do the angles first. So if these two triangles are similar, A and D, angle A and angle D are the same. So this is 50. Okay, angle B and angle E are the same, so this is 70. And then angle C and angle F are the same, so this would also be a Z. We know the three angles of a triangle add up to 180, so we can do 180 minus 50 minus 70. Together that's 120, so that's going to give us 60. So that tells us that angle C is 60, which also tells us that Z is going to be 60. As well, 60 as well. Okay, and now we can look at the sides. So we know the triangles are similar, so we know sides are proportional. So we can set up a proportion. Okay, 5AB is going to match up with 10DE, so 5 over 10. 6 is going to match up with Y. And then X is going to match up with 4. Okay, so we know all of these ratios should be equal. To solve here, we only want one variable. So I'm going to pick the first two ratios for one proportion, and then the first and the third ratio for another proportion. So I'm going to do 5 over 10 equals 6 over Y. And I'm going to do that again over here, 5 over 10. Except this time I'm going to set it equal to X over 4. So I did these two and then these two. Okay, we want to cross multiply. Okay, so 5 times Y and 6 times 10. So we have 5Y equals 60. Divide by 5, you're going to get Y equals 12. Over here, cross multiply, we got 20 and 10x. So we got 10x equals 20. Divide by 10, divide by 10, you're going to get x equals 2. Okay? And that makes sense here in our proportion because we have 6 over 12 and 2 over 4, and that gives us 1/2, 1/2, and 1/2. So we have 12, 2. Okay, the other way would have simply been to find the scale factor. So you could have just started off right off the bat and said, okay, 5 over 10 is your scale factor, so 1/2. These numbers on this side are twice the length, the lengths of the sides on the big triangle are twice the lengths of the sides on the small one. So that means 6 times 2 should have been 12. And then this way we're going the other way, so half of 4 is 2. Okay, but we can always set up our proportions to solve if we don't see the short way. Let's go on to number 11. Okay, the measure of angle D, find the measure of angle D and the length of segment EF. So triangle ABC is similar to triangle DFE. We have two angles here, so I like to do the angles first. So 180 minus 100 minus 20, that's minus 120, is going to give us 60. So that means the measure of angle A is 60. And we know since the angles of similar figures are congruent, we know the measure of angle D is also 60. We know the measure of angle F is 100, and the measure of angle E is 20. So we're looking for the measure of angle D. That's going to be 60 degrees. If we look at the sides, we can set up a proportion. So I'm going to clear this off here for angles, and let's look at the sides. Okay, again, I'm going to put an X and a Y. Okay, and then let's set up our proportion. So 3 compares to 2, so 3 over 2. We have 9 over X, and we have 11 over Y. I'm simply going to split up our extended proportion. So I'm going to do 3 over 2 equals 9 over X. Then I'm going to do another one over here. 3 over 2 equals 11 over Y. We're going to cross multiply here. So 3 times X is 3X. 2 times 9 is 18. Divide by 3 on both sides, and you're going to get X equals 6. Cross multiply here. 3 times Y equals 22. Divide by 3, you're going to get Y equals 22 over 3. Okay. It says round to the nearest hundredths place if necessary. So this one's just going to stay 6. Right, but this one over here, 22 divided by 3. So 3 goes into 21 7 times. Right, so we have 7 and then 1/3 remaining. That's going to be 7.33. So 7.33 repeating. So 7.33. So Y was DE. And then FE was 6. So 6, 7.33. And again, if we put those numbers in here, 9 over 6, that's equal to 3 over 2. And then 11 over 7.33 is also going to be 3 over 2. Number 12. Okay. A little hard to see this one here, but if we look here, this says 6 feet 6 inches. Okay, so we need to figure out how many feet this is, just so we have that they match up. So 6 feet 6 inches here. So there are 12 inches in a foot. So if we do 6 inches, right, there's 12 inches in 1 foot. Maybe that's not the best place to write that. Let me do it over here. Well, let me draw our triangles bigger so we can see them. Okay, so here's the first triangle, and then here's the second triangle. Okay, so you have a tree here, standing at a right angle. You have a guy here, a man, okay, standing at a right angle. Okay, the height of the man is 5 feet 9 inches. So I'm going to put that over here, 5 feet 9 inches. Okay. And he casts a shadow that is 6 feet 6 inches. I'm going to put that over here as well. So the shadow's on the ground. So we have 5 feet 9 inches, 6 feet 6 inches. Okay, at the same time of the day, a tree casts a 50-foot shadow, so the shadow's on the ground, and we want to find the height of the tree. So the only issue here is we got to convert these into feet. So there are 12 inches in a foot. So if we're going to convert 9 inches into a foot, that's 9 inches. There's 12 inches in 1 foot. So that's going to be 0.75 feet. So 5 feet 9 inches is the same as 5.75 feet. 6 inches. There are 12 inches in a foot. So that's going to be 0.5 feet. So 6 feet 5 inches is 6.5 feet. So we can replace these here. We have 6.5 feet, and we have 5.75 feet. Okay, we can set up our ratio. So 5.75 is going to relate to x. And then 6.5 over 50. We can cross multiply here then. So you get 6.5x. 50 times 5.75. Let's use a calculator. 287.5. Then we can divide by 6.5 on each side. We get 44.23 feet. So the height of the tree would be 44.23. Round to the nearest hundreds place, that's 2 decimal places. All right, number 13. Okay, so we're looking for a tree stops. A tree stops a surveyor from directly measuring the length of a lot line. She locates the point E, F, G, H, and I is shown. What are the lengths of E, F, and G, H? So I'm going to put in an X and a Y here. Okay. They don't really give us a lot of information here, but the whole idea is when you're doing the survey, you're going to want parallel lines. So in reality, these lines are going to be parallel, EF and IH. I might have cut off some of that of the part of the question, though, but we do have to know that those lines are parallel. And so our alternate interior angles are congruent. So here and here and here and here. Right, and so our triangles are similar. And so we can make a proportion here. So if we pick a side here, it doesn't matter. Let's just do 12. 12 is going to correspond with 20. Right? 18 is going to correspond with x. And then y is going to correspond with 24. Pick two of the ratios, so I'm going to pick the first two here, 12 over 20 and 18 over x. Right, cross multiply, so that's 12x. 20 times 18 should be 360, maybe, I think. Yep. Divide both sides by 12. 12 goes into 36 three times, so that's going to be 30. Right, and then I'm going to pick the first and the second ratio here, so 12 over 20 equals y over 24. I'm going to cross multiply again, so that's going to be 20y equals, what is that, 288? Divided by 20. I want to say 14.64, 14.4 maybe. Put it in the calculator. Let's make sure 12 times 24 was 288. Divide by 20, 14.4. Right, so x was our EF, so that was 30. And then y was GH, so that's going to be 14.4. And again, we can plug those in here, so 30 and then 14.4. And if you found all those ratios, you would find that they all equal 3 over 5. 12 divided by 20 is 0.6, 18 divided by 30 is 0.6, and 14.4 divided by 24 is 0.6, or 3 over 5. So this small triangle is 3/5 the size of the big one, or you could think of the other way, the big one is 5/3 the size of the small one. So let's look at 14 here. Right, so they're telling us this whole bottom here is 16. So 16 minus 4 is going to give us 12. And we're looking for the height of the tree. Okay, so 5.5 is going to relate to the x. And then 4 is going to relate to the 12. And we know the sides are proportional because we know these triangles are similar. Again, this was my fault. I kind of cut out part of the question. But the idea is the angle that you're looking down at, there's a mirror here, is going to reflect at the same angle that it came in at. If you put a mirror here and you look down at it, it's going to reflect, and it's going to reflect at the same angle. The light coming down here, actually it's going the other way, right? Because it's coming from the sun. All right, it's coming from the sun. It's going to reflect down, hit the mirror, and then reflect off the mirror and then into your eyeball at the same angle that it came down at. So you'll be able to figure out the height of the tree here. So angle similarity, the two triangles are similar. So 5.5 over x and 4 over 12. Again, it's 12 because the whole distance here, the distance between the person and the tree was 16. The distance between the mirror and the person was 4. So 16 minus 4 is 12. So cross multiply, you got 4x. What is that, 66? 66 divided by 4. We got 16.5 feet. All right, so you want to put in 16.5. All right, number 15. All right, we got to draw the triangles for this one. So they're not going to give us the diagrams. We got to draw them ourselves. So given that triangle JHK is similar to triangle POM, I'm going to draw two triangles, JHK and POM. Okay, we know that the measure of angle H is 90 degrees. We know that the measure of angle J is 40 degrees. And we know that the measure of angle M is x plus 5. And we know the measure of angle O is 1/2 y. Okay. Well, we know if the triangles are similar, that the angles are congruent. So we know that this is going to be 40 down here. This will be 90. And this will be 50, right? 180 minus 40. 180 minus 90 minus 40 is 50. So we know this is 50. Right? So we know this is 50. We know this is 90. And we know this is 40. Right? So we know 1/2 y is 90. Right? 1/2 y was 90. And we know x plus 5 equals 50. Right? These angles are the same. So x plus 5 equals 50. 1/2 y equals 90. So multiply by 2, you get y equals 180. Subtract 5 from both sides, you get x equals 45. Key there is to draw out the triangles. If you don't draw out the triangles, it's going to be a lot of trouble. At least a lot more trouble. Number 16. Again, we want to draw out the triangles here. So I have ABC and DEF. Okay, the measure of DE is 4. The measure of AB is x. The measure of AC is x plus 2. And the measure of DF is x plus 6. All right, since we know these are similar triangles, we know the sides are proportional, so we can set up a proportion here. So 4 over x is going to equal x plus 6 over x plus 2. All right, to solve a proportion, we cross multiply. So we're going to have 4 times x plus 2 equals x times x plus 6. We need to distribute. So 4x plus 8 equals x squared plus 6x. Okay, we have an x squared, so we have a quadratic, so we want to move everything to the same side. We want it to be equal to 0. So I'm going to subtract 4x from both sides. All right, that's going to give us 8 equals x squared plus 2x. And then I'm going to subtract 8 from both sides. Okay, we could have just all done that in one step, but that's all right. And so we get 0 on the left. And we get x squared plus 2x minus 8. So now we need a factor. It's a little bit off screen here. There we go. So we get 0 equals x. We need something that's going to multiply to negative 8 and add to 2. So that's going to be, how about positive 4 and negative 2? So plus 4 minus 2. That'll give us x squared. Plus 4x minus 2x is plus 2x, and then minus 8. Okay, and then we can say x plus 4 equals 0. And x minus 2 equals, or x minus 2 equals 0. Subtract 4 from both sides, we get x equals negative 4. Add 2 to both sides, we get x equals 2. Okay, the negative answer is not going to work. You can't have a negative side length. So negative 4 is not going to work. So x is going to be equal to 2. Which means df is going to be 2 plus 6, which is 8. Okay, so if we just go back and look at our original ratio here, you're going to have 4 over 2. 2 plus 6 is 8, 2 plus 2 is 4, and then it's 8 over. Right, so 2 equals 2. Right, and we put several here. I put several on here of overlapping ones. So 17, 18, and 19 are all overlapping triangles. So the best way to do this is to simply look at our ratios that we have. If this is 4 and we're doubling it to 8, this is going to be 6. We're doubling it to 12. So probably the easiest way we have there. Okay, you could draw them separately though. So if we draw the triangle separately, right, you have 8 and you have x. Then if you look at the big one, right, you have 12 and you have x plus 6. And you could set up a proportion there. These are congruent because corresponding angles are congruent, so we have angle-angle similarity. And you could set up a proportion. 8 over 12 equals x over x plus 6. Cross multiply, you get 12x equals 8 times x plus 6. That's 12x equals 8x plus 48. Subtract 8x from both sides, you get 4x equals 48. Divide by 4, you get x equals 12, which is what we had before. So x would be 12, and then 12 plus 6 would be 18. So, right, 8 over 12 equals 12 over 18. 2/3, 2/3. Okay, but you don't need to do all that. You can just double, right? 4 compares to 8, right? 4 is to 8 as 6 is to x. So 4x, 24, x is 12. All right, number 18 here. DE is parallel to BC. Again, that's relevant because that means corresponding angles are congruent. So we have angle-angle similarity. The small triangle here is similar to the big triangle. Okay, AD is 3, BD is 4, AE is 6. Okay. So again, two ways. You can try and find this piece here would work. So you could do 3 over 4. You know, 3 is to 4 as 6 is to 8. I'm sorry. 6 is to x. Right? And you could solve it that way. Okay, but I want to look at the similar triangles. So that works, but I'm going to look at the similar triangles here. So you have the small one. Okay, and right, so the small one here is going to be 3 and 6. Okay, and then if we look at the big one, we have 7, and we can put x here for the whole thing. All right, so 3 is to 7, as 6 here is to x. Right, 3 plus 4, that's where we're getting 7. The whole thing is 7. 3 plus 4, 7. Right, this one's the big triangle here. This was the small triangle. Okay, cross multiply, that's 3x equals 42. So that's x equals 14. So that's x, the whole thing here is 14 then. And then you can do 14 minus 6 gives us 8. The whole thing is 14. And then EC there is 8. 14 minus 6 is 8. Again though, that's if you don't see the quicker way. The quicker way is 3 is to 4 as 6 is to x, right? 3 is to 4 as 6 is to x. So 3 over 4, 6 over x. Alright. But either way, you'll get the right answer. So let's do the last one here, 19. 48 minutes. This is longer than I thought. Okay, AC here is 13, so the whole triangle here is 13. Whole hypotenuse, the big hypotenuse. AB is 5. BC is 12. And DC is 3. Okay, again, I just, you know, there's different ways, but I think drawing the triangle separately is just the best way. You cannot get a better way to me. Sometimes it's faster to do it other ways, but I think the best way and the way I like to think about it, the easiest is by drawing those triangles. So I'm going to draw the small triangle here. Okay, so we have 3. Okay, then I'm going to draw the big triangle in blue. Okay, we got 5, we got 13, and we have 12. Okay, I'm going to put, do it in green here, x and y. Or do we need ED? We don't even need ED. So I'm just going to put x here because this is what we're trying to solve for. Right, EC. So then we can simply set up our ratios. So 12, you know, matches with 3. And 13 with X. A cross multiply, that's going to be 12x equals 39. So that's going to be x equals, you divide both sides by 12, that's 3.25. Right, 12 goes into 36 three times, and then you have 3 left over, so 3 over 12 is 0.25. So EC is 3.25. Okay, and then AE is just 13 minus 3.25. So what is that, 9.75? 13 minus 3.25 is going to be 9.75. So AE then is 9.7. So, again, I can't stress enough. On the last one, it probably wasn't really, it was, so much shorter to not redraw the triangles. But on a problem like this, and the problem that's going to be on the test, just redraw the triangles. It doesn't take a lot of time. It doesn't take a lot of effort. It really, really helps you out just to see them differently. Once you see them like this, you can easily see, okay, 12 matches with 3, 13 with X. But if you try to just do it all on one, you're going to make mistakes. Just so much easier to draw. This is what I do. I draw them separately. Unless it was like number 18, which was super quick to do it the other way. But I always draw them, so it's not always, but I usually draw them out separately. Makes it so much easier. Okay, and that's it for the review. 52 minutes.